example is A equals to 1, 3, 5, B equals to 2, 3. We have to find three things for this problem. First one is we have to find A cross B as well as B cross A. And the second thing we have to find is whether A cross B is equal to B cross A. If it is not equal, then we have to say why it is not equal. Third subdivision is show that n of A cross B which is equals to n of B cross A which is equals to n of A cross n of B. We'll do this problem one by one. First subdivision, what we have to do is A cross B and B cross A. A cross B is familiar to us. How we have to do is A cross B equals to, we'll write the set A cross B is 2, 3. So A cross B equals to set of ordered pairs 1, 2, 1, 3, 3, 2, 3, 3, and the last element 5, 2, 5, 3. Next we have to find B cross A. So B cross A means we have to write the set B first. B equals to 2, 3, cross A value is 1, 3, 5. So we'll write B cross A for this set, which is B cross A equals to 2, 1, 2, 3, 2, 5. Next the element is 3, 1, 3, 3, 3, 5. We have completed the first option, that is we have found out A cross B and B cross A. We will move on to the second subdivision. What we have to find in the second subdivision is if A cross B is equal to B cross A. If not, if it is not equal, and we have to mention the reason why it is not equal. Let us see whether it is equal or not. This is A cross B and this is B cross A. Whereas these both are not equal. As I told you already, 1, 2 will not be equivalent to 2, 1. Similarly, 1, 3 is not equivalent to 3, 1. Therefore, second option A cross B is not equals to B cross A, and the reason why it is 1, 2 is not 2, 1 as well as 1, 3 is not 3, 1. So we have completed with the first two options. We will move on to the third option. In the third option, we have to prove that n of A cross B which is equals to n of B cross A which is equals to n of A cross n of B. So n of A cross B means we know that n of A cross B is nothing but number of elements in A cross B. So number of elements in A cross B is 1, 2, 3, 4, 5 and 6. So this is 6. Next we will write the value of n of B cross A. N of B cross A is nothing but number of elements in B cross A. We will count the number of elements in B cross A. It is 1, 2, 3, 4, 5 and 6. So n of B cross A is 6. This is also 6. This is also 6. Now we have to find out n of A cross n of B. N of A means number of elements in A. Number of elements in A is equals to 1, 2, 3 and number of elements in B is 1 and 2. So n of B is equals to 2. Now we will check this, whereas n of A cross B equals to n of B cross A which is equals to n of A cross n of B. So value of this we found out it is 6 and the value of n of B cross A we found out it is 6. Next n of A value is 3 into n of B value is 2, whereas this is also 6. So we have proved the third option, whereas n of A cross B is 6, n of B cross A is also 6 and n of A cross n of B is also 6, hence proven. Second question is if A cross B equals to set of all ordered pairs 3, 2, 3, 4, 5, 2 and 5, 4. In this problem, we have to find out the elements of A and B. Usually, we'll be given with the sets A and B and we'll find the cross product A cross B. Now, in vice versa, A cross B is given, we need to find the values of A and B. It is also easy to find because if we are given with the sets A and B, we will make a set of all ordered pairs. Here set of all ordered pairs is given, we have to find out the values of A and B. If you look at this, it is A cross B. So, in an ordered pair, the first element represents the values of A and the second element represents the value of B. So, what will be the value of A from this set of ordered pairs? First will be 3 and the next element of A will be 5. Next, similarly, we can write the set B from the given set of ordered pairs 2 and it is 4. So, A cross B is given. We have found out the value of A and B from the given cross product. Move on to the next example. So, in this example, we are given A as x is a natural number such that x varies between 1 and 4, whereas this less than represents 1 and 4 is not included. We all know that natural number starts with 1 and x value varies between 1 and 4, where 1 and 4 is not included because it is only less than. 1 and 4 is therefore not included. Next, moving on to the B set. B set we have to frame in such a way, x is a whole number and we all know that whole number starts with 0, 1, 2, it goes on. And x value varies between 0 and 2, whereas in this set 0 is included because it is given as less than or equal to. Therefore, 0 is included but 2 is not included, whereas it is given as less than. And moving on to the set C, x is a natural number. Again, if it is a natural number, it starts with 1 and x value is less than 3. Less than 3, so 3 is not included. So, we have to frame these sets first and we need to prove two things in this problem. First one is A cross B union C, which will be equal to A cross B union A cross C, and the second one is A cross B intersection C, which is equals to A cross B intersection A cross C. We will prove this problem one by one. Before moving on to the problem, we will write the sets A, B and C. So, set A is equals to, as I told you, n is a natural number. Natural number starts from 1 and x varies between 1 and 4, where 1 and 4 is not included. Therefore, between 1 and 4, if 1 and 4 is not included, we can only write two numbers, which is 2 and 3. Next, moving on to the set B. B equals to, in B set, x is a whole number, whereas whole number starts with 0. 0 is included but 2 is not included. Therefore, we can write it as 0, 1. Next, moving on to the set C. C can be written as, again in C, x is a natural number. X is a natural number means it starts with 1 and which is less than 3. 3 is not included. Therefore, we can write only 1 and 2 for C. So, first we have written the sets A, B and C. Now, we will prove these two subdivisions one by one. So, for proving the first subdivision, we will take the LHS. LHS given as A cross B union C. So, while proving this, we have to keep one thing in mind. First, we will prove the term which is within the bracket, then we will move on to the next portion. So, within the bracket, we are given as B union C. First, we will find B union C, then we will cross product it with A. B union C, B value is 0, 1 union, C value is 1, 2. So, B union C can be written as 0, 1, 2. Since it is an union, we have to write all the elements from both the sets. So, we have completed this portion B union C. As I told you, first we have to complete within the brackets. Next, we will move on to the next step. What is the next step then? We have to do A cross B union C. So, moving on to A cross B union C, value of A is 2, 3, cross product B union C is, we have found it as 0, 1, 2. Now, A cross B union C. So, A cross B union C is, we have to do the cross product for the set A and B union C. We will do that. A cross B union C equals to 2, 0, 2, 1, 2, 2, 3, 0, 3, 1, 3, 2. So this is the left hand side we got after solving A cross B union C. If we get the same thing by solving A cross B union A cross C, this will be verified. So we'll move on to the right hand side. Right hand side it is given as A cross B union A cross C. So first we will finish within the bracket, then will move on to the union portion. Within the brackets, first we will do this A cross B. A cross B means we have to do the cross product for the set A and B. Therefore the set A is 2, 3 cross set B is 0, 1. Doing the cross product for A cross B, we will get it as the set of all ordered pairs as 2, 0, 2, 1, 3, 0, 3, 1. So we have completed this portion. Next we will do A cross C. If it is A cross C, we have to do the cross product for the set A and C. Set A is 2, 3 cross set C is 1, 2. So A cross C equals to, the set of all ordered pairs can be written as 2, 1, 2, 2, 3, 1, 3, 2. So what is the next step what we have to do? Since we have found out A cross B and A cross C, we have to next find out the union between the two A cross B and A cross C. We will do that A cross B union A cross C. So union between A cross B and A cross C. So we all know that union means we have to write all the elements in A cross B and A cross C. So we will write it in order as well. So first pair we will get it as 2, 0. Next pair is 2, 1. Next we will write 2, 2. Next 3, 0. Next 3, 1. Next 3, 2. So we will verify whether both the sides are equal. 2, 0, 2, 1, 2, 2, 3, 0, 3, 1 and 3, 2. So therefore left hand side is is equal to right hand side for the first subdivision. Similarly we have to do it for the second subdivision. We will verify whether it is true for the second subdivision also. What is the left hand side? Left hand side it is given as A cross B intersection C. So first step what we have to do is we have to complete within the brackets. Next we have to go with the cross product. B intersection C. So B intersection C means B value is 0, 1. Intersection C set is 1, 2. If it is intersection means we have to write only the common element in both the sets. Which is the common element in both the sets is 1 alone is the common element in both the sets. Therefore, B intersection C will be equals to 1. So we have found out B intersection C. Next we have to do the cross product with A. So A cross B intersection C. The set A is 2, 3 cross B intersection C, we got it as 1. Now we have to write the cross product. A cross B intersection C equals to, the set of all ordered pairs is 2, 1 and 3, 1. So this is the left hand side we got. If we get the same answer on the right hand side, this will also be verified. Now we will prove the right hand side. Right hand side, the question it is given as A cross B intersection A cross C. So we will go step by step. We know that we have to complete within the brackets first, then we will move on to the intersection portion. So first I will do A cross B. A cross B is set A cross set B. So A cross B is set of all ordered pairs 2, 0, 2, 1, 3, 0, 3, 1. So one portion we have completed. Next what will we do is we will find out A cross C. What is A cross C? The cross product between the set A and C. A set is 2, 3 cross C set is 1, 2. We have to write the set of all ordered pairs for these two sets. How will we write? 2, 1, 2, 2, 3, 1, 3, 2. Next, what we have to do is, we have to find the intersection for A cross B and A cross C. So, we will find out A cross B intersection A cross C. First, I will write the elements of A cross B intersection A cross C. What is A cross B we got? We got it as 2, 0, 2, 1, 3, 0, 3, 1. Intersection. What is the cross product of A cross C we got? 2, 1, 2, 2, 3, 1, 3, 2. So, if it is intersection, we can write only the common elements in both the sets. Which is the common element found in both the sets? 2, 1 is common and 3, 1 is common. Therefore, A cross B intersection A cross C equals to 2, 1, 3, 1. Whereas the left hand side is also 2, 1, 3, 1 and right hand side is also set of all added pairs 2, 1, 3, 1. So therefore this is also verified, whereas this is equals to this term.